Welcome to Bucket Questions, Episode 11. Today we have several questions regarding the behavior of light, and the first question is, how do magnifying glasses work? So in order to understand how magnifying glasses work, and the other questions that we're going to talk about in this episode, we have to review what happens when light hits an object. So let me make an object, and let me get a ray of light. Now remember that we're really talking about white light, which is really a combination of all of the colors of the visible spectrum. So when light hits the object, there are four things that can happen to it. It can bounce off, which is reflect. It can go into the material, which is absorb. It can come back out of the material on the other side, which is transmit. And right here, where it went into the material and back out again, the light bends, and that is refract. And it's the refract that we're going to talk about for magnifying glasses. Magnifying glasses are made of a double convex lens, which means they're rounded on one side and rounded on another side. So let's put an object right here, and let's put our eye right here on the other side of it. Now the light waves are going to come off of the object. And as the light waves come off of the object and enter the lens, they're going to refract. And when they do so, they're going to get angled in all different ways. And some of those light waves are going to get angled into our eyes. And because of the direction that they get angled, what happens is if we trace the angled rays backwards, continue those lines, extend them, what we end up with is what's called a virtual object that is bigger than the actual object. Now the idea of a virtual object sounds kind of strange, and the best way for me to demonstrate this is by using this mirror ball. And so this is going to use reflection instead of refraction to create our image, but the idea is the same. So I'm going to put my pig in the center of my mirror ball. So there he is sitting down there in the center, and you can actually see his reflection as well. But then I'm going to put the mirrored lid on top of the mirror ball. And when I do so, all of the light rays bounce around. What you can see is this pig sitting on top of this dome, but it's not really there. There's no pig there. It's inside, not up here. So this is our virtual image. And so, by the refraction of the light rays through the curved lens, and which then can project a virtual image behind the actual object that's actually bigger than the object, lenses such as magnifying glasses can magnify. And that's also how things like glasses and telescopes and microscopes, that's how all of those work as well. And in fact, this same principle of refraction and reflection is also behind mirages, and why you can actually sometimes see the sun before or after sunset, even though it should have already dipped below the horizon. And speaking of the sun's rays, that leads us to our next bucket question about light. If clouds are liquid water or ice, why are clouds white when water or ice is clear? So before we answer that question, the first thing we actually have to review is the water cycle. Part of this question said if clouds are liquid, water, or ice. And that is actually a concept that some people kind of have trouble with. They think that clouds are gas, and they're not. So let's take a look at the water cycle. Let's get a body of water here, and then we know perfectly well that we've got our sun, I'm drawing it red, but I'll come back to that in a second. And it's going to send down radiation, which is going to cause our water to evaporate. And what is the next phase in the water cycle? The next phase in the water cycle is condensation. And it's condensation that is going to form the clouds. And what is the definition of condensation? Well, it's when a gas cools down enough that it turns into a liquid. Therefore, clouds are liquid. And if they're up high enough in the atmosphere, clouds could actually be made of ice particles as well. And then let's review that I drew my sun red because that's the convenient marker I had, but all of the visible light spectrum from all the way over in the violets up to the deep reds are all going to come from the sun. And water is clear because in water and in ice, if it forms slowly enough and is clear enough, all of these light rays are going to be transmitted. They're going to go straight through the water, and that's part of what makes it clear. However, in clouds being liquid, they're actually made up of lots of tiny little droplets of water. And there's millions of them in one area. But unlike a glass of water, each droplet has its own surface tension. And so when the light waves come in, there we go. Whoops, wrong pen. Try again. This one. When all of the light rays come in, they all get refracted. And they end up bouncing off of each individual droplet at different angles, mostly because of the roundish shape of the droplet. And since all of the light is being reflected off of the droplets, so in clouds, instead of the light being transmitted through the H2O, it is instead reflected all around. And there's so many light waves being reflected by all the millions of droplets that they appear as white. This phenomenon of the sun's rays being reflected around the sky also explains a bonus question of why is the sky blue? If we go back to our chart here, the blue wavelengths are shorter and the red wavelengths are longer. And so the blue wavelengths get scattered more. They're more likely to be scattered or refracted by the actual gas molecules that are present in our atmosphere. And so those light waves tend to kind of bounce around in the atmosphere, and most of them don't actually make it all the way down to where we're seeing them. And as an additional bonus question, that also relates to the color that we perceive the sun as. Since all of the blue rays in this range are getting bounced around the sky, we actually tend to perceive the sun as yellow. But take a look at these photographs. In the middle of the day, when the sun is high in the sky, it's not really appearing as yellow. The sun gives off all of the colors, which means the sun gives off white light. When they're closer to sunset or sunrise, the sun is at a different angle. And when it comes to light refraction and reflection, angle is everything. And that relates to rainbows as well. The different angles at which the sun is giving off of its rays are going to affect the colors that we perceive. So we see the sun as a yellowish tint because all of the bluish wavelengths are being bounced around the sky and not actually making it down to our eyes, but it depends on where the sun is in the sky. Now, for all of you astronomy nerds out there, I will point out that yes, the sun is actually a yellow-orangish star when you see it in space. Those are its actual colors, and those come from a combination of the temperature of the sun as well as the actual elements that are in their ionized state and giving off their different colors glows. But as far as the color of the sun as we perceive it has everything to do with reflection and refraction off of liquid and gas particles in our atmosphere. So our next bonus question, which maybe you thought of this as we were talking, is, okay, if the water is clear, then why is the ocean blue? Well, that again depends on the reflection and refraction and transmission of the sunlight rays through the atmosphere. So if I were to draw a ocean water column, let's see how this goes. Okay, so let's just pretend we have a big ocean column of water, and somewhere up above we've got some sunlight rays coming in. And remember, that's really white light, but obviously that's not going to show up on a white board. In this zone, you pretty much get transmission of all of the colors. But not all of the colors of light make it this far. Many of them are going to bounce around in these layers, and so you only get some of the colors that continue on to the next layer, and then you lose even more colors as they continue on to the next layer until finally you have a layer down here where there's no light transmission at all. And so more and more of the wavelengths of light are being filtered out, if you will. And so there's less light available to be bounced back up to our eyes for the color that we perceive. And if the blue colors are being bounced back the most, then that's the color that we'll perceive the ocean as. However, that's not the whole picture. Take a look at these images of, this one is Acadia National Park, so we're talking about the Gulf of Maine. And this picture here, that's Antigua, where my in-laws spent their 40th wedding anniversary. And note the different colors of the water. It's because the colors that we see in the water also relate to the angle at which the sun's light was received by them to begin with. So if I draw a picture of Earth, and let me roughly put in North America, and Central America, and some Caribbean islands. Okay, clearly a rough picture of Earth. North America is not that big, and South America doesn't get cut off, but you get the point. And now I'm going to give it a bit of a tilt, because it should be more tilted than is. Let's go that way. Okay. And now I'm going to draw a sun, obviously not to scale. And here it is. And we're going to draw some sunlight rays coming off of the sun. What you can see from this ray right here, that's pointing straight at the Caribbean islands, is that these light rays are direct. So if you're looking at this nice Antigua water, the sun's rays are coming pretty much straight down into the water and then being able to be reflected back up. But again, not all the light rays are reflecting back up, because some of them are still being transmitted down through more and more depths of water. Whereas in Maine, we're not getting direct sun rays, we're getting them at an angle. And so our sun's light is coming in, not straight, but at an angle. And then it's bouncing off at another angle. And that can change the perception that we have of the blueness and the clarity of the water. So I hope you learned a little bit more about the way that light behaves and how it can cause phenomena such as different colored oceans, magnification, and different colored collections of H2O. Thanks for joining.